Hi, and welcome to Electronics Handbook. This video will explain what a transformer is and show you how to use them. A transformer is a device which transfers an alternating current or AC signal from one circuit to an AC signal in another circuit. Transformers are mainly used to either change the voltage level up or down, or to add safety. This circuit here shows a transformer in the centre with a resistor on the secondary here and a voltmeter on each side, as well as a 1 volt peak AC power source on the primary. Now, transformers work by using two sets of coils, the primary and the secondary, with a fixed core in the middle. This transformer has 10 turns on the primary and 10 turns on the secondary. Because it has the same number of turns on the primary and the secondary, the turns ratio is 1. That basically means the transformer will not increase or decrease voltage. So if I now simulate the circuit and look at the graph we see, you can see the input side has a 1 volt to 1 volt peak, and the output side also has a 1 to 1 peak. If I now double the number of turns on the secondary side from 10 to 20 and re-simulate the circuit, you can see the input is still 1 volt to 1 volt peak, but the output is now 2 volts to 2 volts peak. What's going on here? This is the standard equation for transformer turns ratio. It states that the turns ratio here is equal to the number of turns on the primary side of a transformer divided by the number of turns on the secondary side of the transformer, which is then also equal to the voltage on the primary divided by the voltage on the secondary. Now, if you remember, our circuit had 10 turns on the primary and 20 on the secondary, giving us a turns ratio of 0.5. Now, if we check back at the circuit again, you can see the primary voltage is 1 volt and the secondary voltage is 2 volts. So our secondary is double our primary, or in other words, we have a step-up transformer with a 0.5 turns ratio. Step up simply means that the voltage is raised from the primary to the secondary. If we now change the turns to 40 on the primary and then 10 on the secondary and simulate the circuit, you can see we get 1 volt on the primary still, but we now have only a 1/4 volt peak to peak on the secondary. So our transformer is now a step down transformer because it decreases the voltage with a turns ratio of 4. So 40 divided by 10 is 4. There is also an extended version of the turns ratio equation that includes current. You can see here that the turns ratio is still equal to the number of primary turns divided by the secondary turns and voltage as well, but it's also equal to the current of the secondary divided by the current of the primary. Now, it's important to note that the fraction here is the other way around. It's secondary by primary instead of primary by secondary. Looking back at our circuit, if we add ammeters, one on the primary and one on the secondary, and then simulate the circuit, you can see on the primary we have approximately 125 microamps, and on the secondary approximately 500 microamps. So if we now do 500 divided by 125, we get 4, our turns ratio. Perfect. Overall, transformers have many applications, whether it be to double 10 volts to 20 volts on your PCB, or step down the 400,000 volts in the UK grid to something you can use at home. One other big benefit and use of transformers is to give what's known as mains isolation. If you have a transformer, even a 1-to-1 transformer transforming a mains voltage, it becomes much safer. This is because if you touch a main signal wire that's not isolated, then current can flow through your body to the ground, electrocuting you. However, if your circuit is isolated with a transformer, then there is no ground connection, so you will not get a shock. Please note though that if you touch both ends of a mains isolated secondary coil, you will still get electrocuted, so perhaps best not to touch live wires either way. Stay safe. Thanks for watching, be sure to like the video if you liked it, subscribe if you loved it, and have a good day. See ya!